I'm going to walk through both ways again on how to solve this, and I'm also going to show you how to solve it using your calculator, or at least verify your answer. So the first way in both steps, or in both types of solutions, is to take what's inside here and replace it with some generic angle. So the replacement that I'm making is that alpha is going to be equal to theta over 2 plus pi over 3. Now I want to solve this guy. Okay, so here's where they are going to split now. So way number 1. That's to figure out what angles alpha can be, or where it's between. So I'm going to solve this guy for theta. I'm going to multiply everything by 6. I'm going to subtract the 2 pi. And then I'm going to divide by 3. So I'm going to get that right there. So that means for way number 1, the first thing we have to do is figure out the interval for alpha. So to do that, I solve for theta over here, and then I insert it into here. So this is going to give me 2 alpha minus 2 pi over 3 is less than or equal to 2 pi. So now what I'll do is I'll move the 2 pi over 3 to each side. So we'll add it. And 2 pi plus 2 pi over 3, this is going to become 6 pi over 3. So when I add these, I'm going to get 8 pi over 3, 2 alpha. And I've got 2 pi over 3 here. Now I'm going to divide everything by 2. So this is going to give me 4 pi over 3 alpha and pi over 3. So alpha is between pi over 3 and 4 pi over 3. So I'm going to write over here, I'm going to write that down. I'm going to erase this so we got a little bit of room here. Okay, so that was our first step, was to get an interval for alpha. The next thing we want to do is figure out what angles give me 1/2 out for the sine value. So what we'll do is we'll draw out our circle, and then we'll figure out where sine is 1/2. Well, sine is 1/2 here. Okay, so there's the 1/2 value right there, and that angle that's generating that is pi over 6. Sine also is at a height of 1/2 at 5 pi over 6. So it's at a whole bunch of different angles, but let's take a look here at the interval for alpha. Alpha has to be between pi over 3 and 4 pi over 3, so that's alpha. Well, pi over 6 doesn't work because pi over 6 falls out here. So that one won't work. What about 5 pi over 6? Well, let's put this as over 6 here. So the 4 pi over 3 is really 8 pi over 6. So 5 pi over 6 falls in here. By the way, if I want to make these all pi's over 6, pi over 3 is 2 pi over 6. And maybe that'll help you see why pi over 6 falls on the outside. So 5 pi over 6 falls right here. And if I go any further, I'm going to end up outside of this interval. So it looks like I only have one solution. So I'll say alpha is equal to 5 pi over 6. But if alpha is equal to 5 pi over 6, now let's go back up here and let's use this to get theta. So 5 pi over 6 has to be equal to theta over 2. Or you can use this down here if you want to as well. Plus pi over 3. So we'll just go ahead and get a common denominator here, which is 6. So this is 3 theta over 6 plus 2 pi over 6 is equal to 5 pi over 6. So we'll multiply everything by 6, and we'll get 5 pi is equal to 3 theta plus 2 pi. So when we subtract, we'll have 5 pi minus 2 pi, which is 3 pi. That's equal to 3 theta. So theta is going to be equal to pi. So what this says here is the only angle that I can plug in right here for theta is the angle pi. So let's check to see if that's correct, if it works out. So I can erase all of this now, I don't need it anymore. So my check here is to try the sine of pi over 2 plus pi over 3 and show that I get 1/2. So this is the sine of 3 pi over 6 plus 2 pi over 6, which is the sine of 5 pi over 6, and that is equal to 1/2. So let's go ahead and erase all that. So we know our solution here, our theta value, should equal pi. Now let's check it using the other method. The other method is basically, you're going to go ahead, oops, I didn't want to erase quite all of that. Let's see here, we divided everything by 3, so it's alright to do that, but I erased this 3 over here. There we go. So again, for way number 2, we're going to go ahead and insert alpha into here. And now what we're going to say, though, for solving this, excuse me, hang on just one second. There we go. Is to say that basically we're going to find the generic values, or all the values, to solve this equation. So we're going to say alpha is equal to the arc sine of 1/2. So that generates values of pi over 6 plus 2k pi, where k is an integer, and 5 pi over 6 plus 2k pi, again where k is an integer. So those are our alpha values. So what's theta? Well, remember, alpha is equal, or theta I should say, is equal to 2 times alpha minus 2 pi over 3. So what I'm going to do is, to get theta, I'm going to multiply everything by 2. Okay, so remember, this is alpha. So I'm going to multiply everything by 2. So that's going to be 2 pi over 6 plus 4k pi and 10 pi over 6 plus 4k pi. And then I'm going to subtract 2 pi over 3. So this is pi over 3 minus 2 pi over 3 plus 4k pi. And this is 5 pi over 3 minus 2 pi over 3 plus 4k pi. So let's do a little bit more reducing here. This is going to give me negative pi over 3 plus 4k pi. And this is going to give me 3 pi over 3, which is just pi, plus 4k pi. So now what we do is we have to go through all of the different k values. And we need to make sure that our output values stay between 0 and 2 pi. So our restriction is to stay between 0 and 2 pi. So we'll start with k equals 0. If that happens, then I have negative pi over 3 for the first set, and for the second set, I have pi. Well, the only one that fits between 0 and 2 pi is this guy. So this is one of the solutions, and that's what we found before. Now let's keep going. If k is equal to 1, then that means I have negative pi over 3 plus 4 pi. That's negative pi over 3 plus 12 pi over 3, which is going to give me 11 pi over 3. And that's already more than 2 pi. So that guy doesn't work. Now if I go over to this one over here, I would have, if I plug in k equals 1, I'd have pi plus 4 pi, which would give me 5 pi, and that's definitely outside this range. If I do a negative 1, that's going to give me negative 3 pi over here, and definitely a negative value over here, so that's not between 0 and 2 pi. So I've already exhausted all my k values, so the only one that's going to work is pi. Now we'll go ahead and grab your calculator, and we'll check it with that as well. So what we're going to do is we're going to grab the original problem, both sides of it. So on one side I'm going to have the sine, so let's just put it up on the first one. I'm going to have the sine of my angle divided by 2 plus pi divided by 3. And then I want to see when that is equal to a height value of 1/2. So my window is going to be between 0 and 2 pi, so that's good. So everything looks right. And if I graph these, they only cross at one spot. And each of these dashes were pi over 4, so pi over 4, 2 pi over 4, 3 pi over 4. Looks like it crosses at 4 pi over 4, which is just pi. So the solution that I got up here for my angle seems to not only match the graph, but it also matches both of my techniques for solving for it algebraically.